So again, what do we need to do on this type of questions? We need to find the minimum or maximum point, and then we need to find the y-intercept. Okay, so only those two things. Now, maybe you are asking, why do we need the line of symmetry? Now, we need the line of symmetry to properly draw our curve. Okay, and in some instances, they will be asking the line of symmetry also. Right, so it's better that that we know how to find for the line of symmetry right away. Okay, so again, question is letter D. So here's the question again. So y is equal to x plus 1 squared minus 5. So again, the format, this is the standard form. This is the completed the square form. Okay, so again, the format is y is equal to ax minus h squared plus k. So we just pattern this with this. That's it. All right. So from here, what is the value of a? A is 1, right? So if our a is positive, again, class, for a, our main concern here is to know whether it is positive or negative. We don't, I mean, actually, we don't need a number here. We just want to know if it's positive or negative. Okay. Since this is positive, that means our graph is happy. So it's like this. It opens upward. Okay. And then, again, we need to find h and k. So h and k will come from here and here. So if you follow this format, okay, that means that h is negative 1. All right. And then k is negative 5. Okay. All right. So you have your minimum point at negative 1, comma, negative 5. Right? Okay, so we're done with this, and then we need to find the y-intercept. Okay, so how do we find the y-intercept? Again, there is a formula, ah squared plus k. You just need to substitute this here, and then you'll get negative 4 as your y-intercept. Okay, that means that the graph will intersect the y-axis at negative 4. And then last is the line of symmetry. So the line of symmetry is always equal to the value of h. If h is negative 1, that means that the line of symmetry is also x equals negative 1. All right, so that's everything that we need to know in order for us to graph this curve. So what I did here is to first plot the minimum point, because yeah, this is the turning point of the curve, right? So you draw this negative 1, then negative 5. All right, so here's your minimum point, negative 1, and then negative 5. So next thing that I need to know is, where is my y-intercept? So negative 4. So you plot negative 4 here. Okay. All right, so that means that this and this should be part of the graph. And then what's next after I have plotted my y-intercept? Next is try to plot the line of symmetry, or try to draw the line of symmetry, which is just a straight line or vertical straight line, all right, from the minimum or maximum point. So it's basically this line, all right. Again, this is exactly in the middle of the graph, so it makes it symmetrical. All right, so from there, so you connect your minimum point and your y-intercept, creating a smooth curve like this. Okay, it doesn't matter, class, if it's like this or maybe like that, as long as you intersect the minimum and the y-intercept. All right, but take note, class, if you draw your graph or half of your graph like this, it should reflect the other side also as similar as possible, like that. Okay, don't do it like your graph is like this on, let's say, on the right side, and then the graph on the other half is like this. Of course, it's not symmetrical anymore. All right, I'm not asking you to be perfectly symmetrical, but at least try to be as close as possible from the other side, because the other side is just a reflection of this side. All right, so try to make, at least make it balanced so it looks better on your graph. All right, so anyway, that's it. And please don't forget to write the equation beside the graph. All right, so that's it for letter D. Okay, do you guys have any other questions about this set of examples? Hmm? Okay, so if there's no more question, I'll move on to another set of questions. All right. Now, the next set of questions is, what if the questions are not these? I mean, like not like this. I mean, it's written in another format or in another way. Okay. Um, like this one. All right. So what if you're given this? Not this one. Maybe this one instead. Okay. So this is example number 3. It's from your book. Okay. So what if you're given this equation? So it's different from the previous examples, right? So the previous examples format is y is equal to ax minus h squared plus k, right? So how do we change this into this, right? So there's another set of work that you need to do before you can graph this one properly. Okay, so again, this format here is what you call completed the square format, right? So that means that we need to complete the square of this equation. If you still remember completing the square from EMATS, right? So that's what we need to do first before we can graph this equation. All right. So what do we need to do first? So we bring down, or we just copy this here. Okay, and then I'll just put equals 0 here. It's just a placeholder. Okay. All right. So equals 0. And then what do we need to do next? So we transpose 9 to the other side. That's why it becomes 9 here. And also, we bring down this, and of course, we need to complete the square by finding which number should we put here. It's a perfect square. That's what it's called. And we also need to do the same here. If we add, let's say, if we add 1 here, we also will add 1 here. Okay? Because it's an equation. All right. But the problem is, your x squared has a coefficient. It has -4 now. So what should we do with the -4? Okay, this is the additional step. You need to get rid of this -4. All right. How do you get rid of this? You need to factorize this side here. Okay, so basically, to get rid of -4, you factorize -4. So your common factor is -4 because 4 and 12 are both divisible by -4. So divide this by -4, you will get x squared, right? So -4x squared divided by -4. So -4 gets cancelled. You're left with x squared. All right. And then 12x divided by -4. So 12x divided by -4. So 12 divided by -4 is -3. So it's now, sorry. So it is now -3x. All right. Supposed to be -3x. All right. Okay. So, and then what's next after that? Okay. So let's say we have done dividing them by -4. So how do we find this 3/2 squared? So again, class, if you still remember, we divide this by 2, right? So we divide this by 2 and then we square that, all right? Now, for this one, let's not evaluate it anymore because basically we don't need the evaluated form of this. So we just write it as 3/2 and then squared, all right? You don't have to answer that. You don't have to make it 9/4. Okay, just keep it as 3/2 squared. Again, it came from here. So you need to divide the middle term by 2 and then square that. Okay. All right. So basically that's it for this one. Now, question. You should also add this one right here, but there's another thing that you need to know. you have negative 4 here. That means you also need to multiply that by negative 4. Okay, so don't forget this. Okay, if you multiply this by negative 4, okay, because this times this, right? So you also need to do the same thing here. Okay, so don't forget this one. Okay, because you factored out negative 4, that means that in order for you to get this, you need to multiply it by negative 4. So that's what you need to also do on the other side. Okay, is this one. Okay, and then all right, after that we need to factorize this now. So bring down negative 4, and then you factorize this. So square root of this is x, and then half of this. Okay, so it's 3 over 2. Okay, so this is what you need to write there. So you don't have to get the square root of this again. You just write 3 over 2 and then square. Okay, and then equals 0. Now why is this equal to 0? What happened to this? Now this one, this is 9 minus 9. If you evaluate this in your calculators, this will become 9 minus 9. So that's why this is 0. Okay, so after this, basically you're finished. So express this equals to y. So y is equal to, so yeah, that's it. That's your answer. And take note, class, you don't have value for k. It's missing. That means k is 0. All right? All right, so that's it. Okay, so this is your completed the square form. Okay, do you guys have any question? Okay, maybe you're wondering, why is this positive instead of negative? It's because you have a negative 4 here. So negative, negative, this is positive. All right, that's why it's positive. Okay, so this is the completed the square form. Do you guys have any question on this part? Any question from any step? Class? None? No question? Okay. All right, so from here, so we have finished the completed the square form. And then we just do the same thing that we did before. We need to find for A, H, and K. All right, so this is A. A is negative 4, right? So if it's negative 4, that means that the graph is sad because it's negative, right? So our graph will look like this. And then for H, H is negative 3 over 2, or you can use negative 1.5. Okay, whichever you prefer, all right? And then, of course, K is missing, so it's plus 0 here, right? So if K is, we don't have K here, that means K is equal to 0, all right? So that means that your maximum point, again, is at negative 1.5, right? So negative 1.5, and then 0, all right? So let me erase this. I'll just do it all over again, okay? All right. So that's it. That's your maximum point. Okay, and we know that the graph is sad, so your maximum point is over here. And what do we need next? We need the y-intercept. So to get the y-intercept, you can use the formula, or you can just set x to 0 here. It's just the same thing. You'll get the same answer. Okay, doing so, you'll get negative 9 as your y-intercept. And then I want to know the line of symmetry. So the line of symmetry is equal to this. So if it's negative 1.5, that means that my line of symmetry is also negative 1.5. So basically, we have all the things that we need to find, to graph the equation, right? All right, so let's draw it now. So basically, look first to your maximum point. It's at negative 1.5 and 0. So that means it's over here. It's on the left side. Okay, it's on the left side. So I'll draw this like this. Okay. So this is, let's say this is 1. So this is 1.5. Okay, and then this is where my maximum point is. All right, this one. And then what do you need to know next? You need to plot the y-intercept, it's -9. Y is -9. So therefore, looking at your y-axis, this one, you just try to write -9 here. So let's say this is where -9 is. Okay, -9. So I'll point there. So that's it. Your minimum, oh, sorry, your maximum point, and then your y-intercept. And then what's next? I'll draw my line of symmetry to make it more, balanced. Okay, so sorry, it's -1.5. It's not 0.5. Sorry, I'm wrong here. It should be right here. So let's say this is 1.5. Okay, and this is 1, right? It's not 0.5. This is 1, and then this is 2. All right. Okay. Okay, so 1.5 should be here, or -1.5. All right. So here you go. Okay, and then what's next? The line of symmetry, -1.5. So just draw straight line, straight vertical line. Line of symmetry is always vertical. Okay, so x is equal to 1.5. And then you draw half of your curve now from the maximum point intersecting the y-intercept. Okay, only something like that. All right. Of course, it won't be perfect, but at least we can try. Okay. Nah, so it should be like this. All right. Wait. All right, and then just reflect the other half. Okay, and then is it reflecting? All right. Wait. Nope. All right. So at least it's reflecting now. And then after that, don't forget to write the equation of the curve. So y is equal to -4x² plus 12x minus 9. All right. So that's it. So that's how you draw your graph. Okay. So do you guys have any question? Okay, so no question, yeah. All right. All right, so I have another example here. Okay, so for this one, it's asking for other parts of the curve. Okay, it's basically the same question as this, but this time it's asking for the x-intercepts. So we need to find for the x-intercepts. Okay, so yeah, so let's have number 4, example number 4. Okay, so let me read. By completing the square, sketch the graph of y is equal to 2x² plus 4x minus 16, indicating the coordinates of the turning point and the x-intercepts. X-intercepts. So we need to know where are the x-intercepts. And then let's revise. How do we find the x-intercepts? Okay, when you're looking for the x-intercepts, that means that these are the points that's on the x-axis, right? If the points are lying on the x-axis or the x line, that means that y is equal to 0 for the x-intercepts. Okay, so that's what we'll do here. Actually, it's here. So, okay, but let's start. So how did I get the different parts of this graph? All right, so again, we need to change this into complete to the square form. So again, this same format. Okay, so let me write it here. So I wrote it here, class. And what's next? So you can put okay, imaginary 0 equals to 0 here. So the next step is to transpose this to the right side. So it becomes 16, right? And then bring down, okay, so I think I skip a step here. So you bring down 2x² plus 4x, right? And then, so I need to get rid of, again, x² has a coefficient. So you need to get rid of this 2 here by factoring or factorization, right? So 2 is the common factor between 2 and 4. So 2x squared divided by 2, you'll get x squared, right? And then 4x divided by 2, you'll get 2x, okay? And then plus an empty number here, a perfect square number here, equals, again, 16 came from here. And then plus, okay, why do we have 2 here? Because we also factored 2 here, okay? And then also the missing number, or the perfect square number, that we need to fill in here. So obviously, how did I get 1 squared? Okay, look at the middle term. You divide this by 2 and then square. That means it's 1 squared. Okay, so because 2 divided by 2 is equal to 1, and then 1 squared is, yeah, it's 1 squared. So if this is 1 squared, this is also 1 squared. All right, so what's next after that? So this side, the left side, you can factorize this now. So bring down 2, and then you factorize this, it becomes x, and then plus, of course, this is plus, and then 1. Okay, so that's it. X plus 1, and then don't forget the square outside. Okay, so it's the factored form of this side. And then how about the right side? So evaluating this, you'll get positive 18. All right, so to change this into completed the square format, you just need to transpose 18 to the left side. So therefore, y is equal to, okay, so 2 times x plus 1 squared minus 18. So yeah, this is the completed the square format. Okay, so we just follow this with this. So they're the same now, class. Okay, so any question, class, on this process here? All right, again, don't forget to remove the coefficient by getting the common factor and then dividing this here by 2. Okay. Okay, let me just write the imaginary 0 here. Okay. So yeah, basically we're done with the completed the square form. So next is we need to find the different parts of the graph. So we need to find A, H, and K. So A is 2. So yeah, A is positive. So therefore our graph is happy. So it's like that. So therefore we are looking for the minimum point, right? So the minimum point can be given by H and K. So what is H? H is negative 1 here, and then K is negative 18. So therefore, your minimum point is at negative 1 and or negative 1 comma negative 18. All right. Okay, so we have now the minimum point. So we need to find the y-intercept. So the y-intercept is at negative 16. Okay. So again, this is the formula AH squared plus K. So just substitute it here. Your y-intercept is negative 16. Okay, so that's why it's here. And then the line of symmetry is x is equal to negative 1. It's equal to h, right? Okay, so basically that's what we did before, right? But for this question, it's also asking for the x-intercepts. Okay, x-intercepts. Oh, by the way, whenever you see the turning point is the maximum or minimum point. Okay, it's this one. All right. All right. If you don't see the word minimum or maximum point, it's other word is turning point. Okay, so that's it. All right. Okay, back to the question. How do we find the x-intercepts? Again, x-intercept is where the points lie on the x-axis. So therefore, y is equal to 0 on those points, right? So that's what I did here. So y is equal to 0. So using the same equation here, I made y equal to 0. So it's now 0. Okay. So how do we answer this? Well, you can make the number smaller by dividing the whole equation by 2. That's why this is now x squared plus 2x minus 8 equals 0. And that, what did I do here after this one? So I factorize. Okay. I factorize this, okay, since this is way simpler and much faster to factorize than to use the quadratic formula. So what are the factors of -8? That the sum is +2. So the factors of -8 that the sum is +2 are 4 and -2. Because 4 times -2 is -8, and then 4 minus 2 is +2. So yeah, these are the correct factors. That means that x is equal to -4, and then the other x is +2. So these are the coordinates of the x-intercepts. All right, so how do we graph this? So start with the minimum point over here. Okay, so -1 and then -18. So minimum point is here. Y-intercept is -16. It's over here. All right, and then the x-intercepts. Okay, x-intercepts. By the way, class, let's draw first the line of symmetry. Okay, so you draw the line of symmetry. So this, and then the line of symmetry, and then you start graphing your x-intercepts. So the x-intercepts is, of course, side by side by the line of symmetry. So -4 is here, and then +2 is over here. Take note, class, that the line of symmetry is again in the middle of the curve. So that means that this and this have the same distance. Okay, so they are equal. Okay, now you don't have to use a ruler for this. Just try to approximate them and make them look equal. All right. So, and then once you have this 2 points here, you just draw half. Okay, so I'd rather start with this part, intersecting the y-intercept and that x-intercept over there. Okay, so that's it for the half of the curve. And then just reflecting the other side, you draw the other half. And then that's it. And don't forget to write the equation. So yeah, that's the graph of this example. All right. So any question, class, for this one?
How did you get 1 to the power of 2, sir?
Again, Mario, Edgar.
How did you get 1 to the power of 2?
This one from here.
Yeah, that one.
Okay, this one. All right. Always look at the middle term. This one. Okay. So your coefficient here is 2, right? So always divide this by 2 and then square. Right? So it's basically 2 divided by 2 and then square. So that's equal to 1 squared. Right? Yeah, so that's how I got this. Okay, maybe let's go back to the previous question. This is your middle term, right, Edgar? Okay, so you divide this by 2. So 3 divided by 2 square. Right? So that's how I got that. Okay. So same with the example. So this I got this from this one. So 2 divided by 2 square is equal to 1 squared. Okay. That's what. Yeah, that's it. Okay, yes, it's a bit different because back in EMATS, we used to evaluate this, right? You will write here 9 over 4. But here in AMATS, I think it's better that we just leave it like this. Okay, because actually we don't need the 9 over 4 on this side. What we need here is the 3 over 2 for this one. Okay, because if you evaluate it to 9 over 4, you'll just go back to 3 over 2 because that's what you need here when you factor this one. Yeah, so that's how I got 1 squared. And please don't forget the 2 here. Okay, if you factorize this, don't forget that the number here on the right side is also multiplied by the common factor on the left side. Okay, let's say this is let's say it turns out to be 3. Now this is also multiplied to 3. Okay. Okay, so for number 5, given that 4x squared minus 16x plus 15 is equal to a times x minus p squared plus q, for all values of x, find the values of the constants a, p, and q. That means a, p, and q are just numbers. Okay, hence, State the coordinates of the minimum point of the curve y is equal to 4x squared minus 16x plus 5, sorry, plus 15. Okay, so basically class, what you need to do here is you need to change this into the completed the square form. You need to complete the square and follow this format. Now, don't be confused if the question is using different letters because it's just the same thing. Instead of H and K, it uses P and Q. All right, but it's just the same thing. Okay, H, K, and then letter A. So, and then once you're done with this, once you have completed the square, you need to find the minimum point of the curve. Just that. You don't have to sketch the graph anymore. All right, so go ahead, answer number 5. And also on number 5, you already have an idea that it's the minimum point. If it's minimum point, that means that your graph is happy, right? It says here minimum. Anyway, just do number 5 first. Okay, so you don't have to find um the other parts of the of the graph. You just need to find P and Q, or in other words, H and K. Only that. And then once you have those H and K or P and Q, that's it. That's your minimum points right there. The first thing that you need to do is again complete the square. So change that into completed the square form. Then don't forget to factorize 4x squared minus 16x. You need to get rid of that 4 from the 4x squared. Okay. So it will be just a times x minus p. All right, or simply yeah, x minus 2. All right. You may want to use Desmos and see the answers right away, but you still need to show how it's done. Okay, finish. All right. So let me show you guys my answer for number 5. Okay. All right. So number 5 again. Let's read. So given that 4x squared minus 16x plus 15 is equal to ax minus p plus q for all values of x, find the values of the constants a, p, and q. Hence, state the coordinates of the minimum point of the curve y equals 4x squared minus 16x plus 15. All right, so let's break down the question first. Um, okay, okay, class. So this one, class, is the completed the square form. Okay, but instead of using h and k, it used the letters p and q, but it's just the same thing. Now, the question here is you need to find for the values of a, p, and q. So therefore, you need to change this equation here to this completed the square format, and then find the values of a, p, and q from there. And then once you get the values of a, p, and q, you need to state the coordinates of the minimum point. Okay, so the minimum point can be um, found by finding the value of p and q, and then that's it. You don't have to sketch. All right, so how did I answer this question? All right, let's go to number 5 again. So this is the question. So I wrote it down again, equal 0. So this is just an imaginary 0 for me. Okay, because the first thing I need to do is to transpose this positive 15 to the other side. So I'll get negative 15. All right, and then bring down this one also, and then plus the perfect square numbers here. All right. So, and then what's next? So I have 4 here with my x squared. Now, in order for me to complete the square, I need to get rid of 4 first. So how do I get rid of 4? So that means I need to factorize 4 from this side. So I'll factorize 4 by, that's my common factor. I'll divide 4x squared by 4, and then you'll get x squared. And then dividing negative 16x by 4, you will get negative 4x. All right, and then plus, okay, the missing number here, plus, all right, this time it's times 4. So the missing number here on the right side is now multiplied by 4 because you factored out 4 from this equation. So please don't forget this one, okay? This one. All right, so how did I get 2 squared as my missing number? So again, looking at your middle term is the one with x. Okay, it's maybe it's the one, it's the b in your quadratic um, equation. So 4 divided by 2 is equal to 2 squared, right? Divided by 2 and then square it, you'll get 2 squared. Okay, 2 squared. So this is also 2 squared. Okay. So therefore, I have completed the square. So I just need to factorize this. So you bring down 4, you factorize this. So x squared becomes x, and then minus, because this is minus, and then, yeah, square root of this is also 2. And then don't forget the square outside the brackets. And then when you evaluate this is negative 15 plus 16. That's why this is 1. And then the next thing I need to do is to transpose this back to the left side. So it becomes negative 1. And then that's it. That's your completed the square format. Okay. Now writing this here so you guys can compare side by side. So A is 4, P is 2, and then Q is negative 1. Right? So we need to identify what is A, P, and Q. So A is equal to 4. So these are your answers. Okay, these are your answers, including the minimum point. Okay, so A is 4, P is 2, Q is negative 1. So here and here. So your minimum point is at 2, comma, -1. Okay, any question, class? All right, none? Okay. Now, I have maybe two more questions, but I'll just make it fast. We are not going to answer. I'll just uh, okay. Please do take down notes. Class, when the question is find the least value, okay, the least value. Okay, the question here is when you say least value, you need to find k. All right, and then here corresponding value of x is the h. All right, so that's what it means there. Okay, so you basically need to change this to completed or completed the square form. Okay, complete the square. All right, and then for number 7, okay, so um, greatest value is also k. All right, but what's the difference between least value and greatest value? All right, their difference is from how their graph looks like, because from number 6, this x here or x squared here is positive, right? That means if it's positive, your graph is happy, right? So that's why your least, it's called least value because it's below, it's in the minimum point. That's why it's called least value, all right? Okay, so these are some keywords that you guys need to, you need to know, okay? And then for number 7, this is called the greatest value, okay? It's because when you graph this, look at A. A is -2, right? -2. So if it's negative, your graph is sad. That means that your maximum point is here. Okay, if it's maximum point, that is the same with the greatest value. All right. So that's why they're both k, but one is called least and then one is called greatest because of the graph. Okay. So that's it for number